All right, guys, but I just passed out to you the notes for what we're going to do today. We're going to spend, hey, guys, we're going to spend a couple days kind of in an in-between thing here before we jump into Chapter 5. We're on Chapter 5 next, which is where we're solving things with like x cubed, x to the fourth, x to the fifth, and bigger polynomials like that. But before we can jump into solving that stuff, we need to take a little time out and talk about a little bit of graphing. I know graphing is not everyone's favorite. We do very little graphing by hand, just a little bit. We're going to spend like today and tomorrow working on some graphing by hand. But for the most part, we do a lot of the graphing on the graphing calculators. Okay? So kind of humor me for a couple days on some graphing by hand stuff. All right, so preparing to graph. What is standard form of a quadratic function? You guys know this? Nope, that's standard form of a linear. That's linear, not quadratic. They said y equals mx plus b. That's linear. Close. It'd be y equals ax squared. There it is. Plus bx plus c. There you go. Yeah, so you guys kind of spurted right away the y equals mx plus b. It cracks me up. Students can always tell me that, but I'm like, what's that mean? And they're like, I don't know. I learned it at some point. It's important. Right? That's the standard form of a linear equation. So if you graph something in that form, it'd be a straight line. Okay? Graph something in this form, it is curved. Do you know what that curve is called? That's the next blank on here. What's it called? Starts with a P. Really? Nobody yet? Parabola. There it is. That is not a parabola. Do not call that parabola. So, somebody every year is like, oh, yeah, parabola. I'm like, no, that's called a parabola. Parabola. All right, that's a parabola. All right, guys, the path of any object flying through the air can be described as quadratic. Quadratic is anything that's x squared, right? If we're graphing something x squared, it's quadratic, and its graph is called a parabola. Now, I have a picture of Angry Birds on there. Why? Yeah, Angry Birds is nothing but math, you guys. Yeah, it's fun to play and like mindlessly think about it, but this shape that they're making, that's a parabola. It's a very flattened parabola, but it is. Pick up your younger sibling and chuck them through the air. They're going to make a parabola, right? They're going to fly through the air and they're going to come back down. Don't try that, okay? Be nice to your siblings. Don't do that to them. All right, just to make sure, I know it's Monday, let's kind of get our brains working here. I know we know how to do this, but can you put the equation in standard form and then tell me what A, B, and C are? We've done this, right? We did this all in the last chapter. So this first one, how should it be written? Y equals 2x squared plus x minus 11. Right? You want your x squared, then your x, then your number. All right, so what's your A value? 2, 2x. A is the number in front of the x squared. What's your B? 1, and your C? Negative 11. Right? We had to do that all the time we were doing quadratic formula. Nate, I yell at you all the time to stop putting x's in your formula, right? All right, what about number 2? Good. What's your A value? What's your A value? Just 7? Negative 7. Here it is. And your B value? 6. What about your C value? 0. There is no number. Good. All right, what about number 3? It's already there, right? It's already in the right form? Okay, what's your A value? 2/3, just the number in front. What's your B? And your C? 0. All right, so just making sure we're clear on what all those things are, right? If something's missing, that actually still is a number. Don't just like leave that part blank. It's a 0. Okay. So what does standard form tell us about the parabola? So when I look at an equation, I can kind of get an idea of what it looks like without doing any math. Okay? So the point where the parabola changes directions is called the what? So as it's going up, it hits a point, and then it starts coming down. What's that top point called? You guys know this. I know you do. Somebody said it. Vertex. Yeah. That's the vertex. Now, same thing, like we always talk about throwing things, right? And it always makes that path. Can a parabola still go down and then back up? Yeah, that's a parabola as well. So then its highest, or its vertex would be the lowest point on there. All right, it opens which direction if A is positive? Think about what's positive. Up, right? It opens up if your A value is positive. So meaning opens up, that would be where it's like going down and then back up again, right? Because it's opening upwards. And has a blank point value. It has a minimum, right? The vertex, think about if it's opening up. Let me kind of draw a sketch for you here. If it's opening up, it looks like this. It means my A value was positive because it's pointing upwards. Think where the vertex is, way down here. Is that the highest point or the lowest point on the graph? The lowest, so it's the minimum point, right? It's as low as it's going to go. All right, opens which direction if A is negative? It's going to open down. And the vertex, will it be the highest point or the lowest point? It's going to be the highest point. It's going to have a maximum. And again, if you think about what the graph looks like, my A value is negative, and then that vertex then is the highest point on the graph before it falls back down again. Again, there are some pictures on there so you can see the difference. So if you're graphing them, these are like graphed on a graphing calculator where you can see the vertex right here in the center. Right, so if your A value, the number in front of your x squared, is positive, it's going to open up. If it's negative, it's going to open down. It just takes that entire graph and it's going to flip it on the other side. All right. So decide whether the parabola will open up or down and whether it has a maximum or a minimum point. So just by looking at it. So what about number 4? Is it going to open up or down? What's your A value? Positive. My A value is positive, right? That's a positive too. So it's going to open up. Positive. Up. Positives. Up. So is the vertex a minimum or a maximum? Minimum. That's the lowest point. Oh, my board does not want to write this morning. We'll go min. I don't have to write as much. Right, so it's going to open up, and it's going to have a minimum value. All right, that vertex is the lowest point on the graph. All right, what about number 5? Good, because what's my A value? My A value is a positive 2, so it's going to open up, right? And will it have a minimum or a maximum point? Minimum, right? That's the lowest point on there. What about number 6? It's going to be down because this value is negative, so it's going to look like that. So down. And the vertex is the maximum. And I realize I had that on there where you could have circled it, but I just wrote it off. I got excited. I just wrote it off. All right, so just by looking at the graph, looking at your A value, you know whether it opens up or if it opens down. Okay? So you should be able to tell me that. All right, so here's where the math starts to come in, all right, because we really haven't done any math yet. So we're going to have to find the vertex of our graph. I want to know exactly where's the ordered pair, right, the xy value on a graph, where's that minimum or maximum point, okay? So to find the x coordinate of the vertex, it is x equals negative b over 2a. Jot it down, circle it, star it, highlight it. You have to know how to do that. That's just to find the x coordinate, right? So when I'm thinking of points, right, you guys know ordered pairs, right? It's always x and then y. So this is finding just this part of it. Okay, that's going to give you your x value of your ordered pair. Then to find the y part, you have to plug whatever you got for x, you got to plug it back into the equation. So let's go ahead and do one over here so you can kind of see how it works. So finding the x coordinate first, we're going to do negative b over 2a. Now, see this negative? Don't ignore that. Okay, I have a lot of students who are like, oh yeah, negative, blah, 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 I don't have to really worry about that. Have we seen a negative b over 2a? Does that look familiar? What's it part of? Quadratic formula, right? Quadratic formula starts off negative b, blah, 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 all over 2a. You've seen part of this. All right, so my b value here is 8. So what's negative b? Negative 8 over 2 times a, which is 2. Now, some of you are the most calculator-dependent people I've ever seen in my entire life, and you know who you are. Do not type all of that in just as like a division sign with, like it's going to do it in the wrong order, okay? If you're that calculator-dependent, you need to use a fraction button. However, you know what 2 times 2 is, right? Right, so we get negative 8 over 4, which is negative 2. So the x part of the coordinate where that vertex is located is negative 2. Did I need a calculator there? No. Stop being so calculator dependent. Sometimes it's just easier to do it in your head. All right, so now we got to find the y part, right? I need the other part of my ordered pair. Take that, and we're going to plug it back into the equation. So in other words, I'm coming back up here. This is where I'm like, please grab your calculator, type this in. Because I'm going to do 2 times, where I have negative 2 squared, plus 8 times negative 2, plus 5. Right, I'm just literally, I'm taking this equation, and I'm plugging in my x value. Okay, so you should type in exactly how I've written there. So 2, make sure you put the negative 2 in parentheses, squared, plus 8 times negative 2, plus 5. What did we get? Should get negative 3. So where is your vertex located? It is located at negative 2, negative 3. So it'd be back 2 and down 3. You guys okay? All right, you're good. All right, so let's practice finding the vertex. So we're eventually going to graph by hand today, guys, but we got to slowly find parts and pieces, okay? So finding the vertex. Again, we need to start with the negative b over 2a. So let's start there. So what's negative b? Negative 4 over 2 times my a, which is 2. So that's going to be negative 4 over 4, which is negative 1. So I know that is the x part of my vertex. How do I find the y? Just plug it back in. So I'm just going right back to the top. So 2 times negative 1 squared plus 4 times negative 1 minus 7. And we get, it should be negative 9. So your vertex would be located at negative 1, negative 9, right? Back 1, down 9. Questions? Some of you are giving me some funny looks right now. Which, did you get the x value? Okay, so you're just stuck on how to find the y? I literally just plugged it into this equation. See my work right here? Wherever there's an x, you're plugging in your x value. That's all I'm doing. I literally, anytime there's an x, see my x value I found is negative 1, I put it there. 4 times negative 1. And I just type in that whole thing in my calculator. Wherever there's an x, I'm putting in the negative 1 that I found. So let's look at number 8. So you got to start with negative b over 2a. So what's negative b? 6 over 2 times a, and a is 1. So let's clean up the bottom. That gives me 6 over 2, which is 3. Negative b. Yeah, it's always changing it to whatever its opposite is. Guys, at any point, do not wait until we're done today to ask me questions, because we're going to go numerous steps beyond where I'm at right now. So if you're lost, make sure you're stopping me, okay? All right, and then how do I find y? Just plug it back in. So I'm going to this equation, so it's going to be 3 squared minus 6 times 3 plus 5. Negative 4. You guys know how to plot points, right? So we're going to have to plot some points today. It's an algebra 1 skill. You should be fine. All right. Let's look at number 9. All right, so number 9, if I'm looking at this one, again, I have to always start with negative b over 2a. What's my b value? 0. Right? There is no plain x term there. So it's going to be 0 over 2 times 3. So 0 over 6, which is 0. Well, that was fun and easy, wasn't it? So then when I find the y part, I got to plug this back in. 3 times 0 squared minus 4, which is negative 4. So easier or harder if the b value is missing? Way easier. All right, why don't you guys try number 10 on your own? All right, guys, let's go ahead and talk through this, see how it happened. All right, so we always start with negative b over 2a. What is negative b? Positive 3 over 2. What's your a value? Just 1? Negative 1. So I get 3 over negative 2. Do we like negatives on the bottom? That's very awkward, isn't it? We can write that then as negative 3 over 2. Guys, when it comes to fractions, it does not matter if the negative is on the bottom or on the top, or if you just kind of write it out in front. Does not matter. Certain calculators do not accept a negative on the bottom. The graphing ones, I don't think they mind as much. The scientific calculators will throw a holy fit if you try to put a negative on the bottom. It does. It doesn't like it. All right, so then we need to plug this back in. So 1 minus 3 times negative 3 over 2 minus negative 3 over 2 squared. All right, now, those of you who are a bunch of whiny babies, you can use your fraction buttons, and it's okay to hit a few extra buttons. Parentheses are your best friend, so do not lose those. All right, and I got 13/4. I typed in what it says. Try typing it in again. Did you get negative 3 over 2? Try it again. This is why we practice now. If you did not get 13/4, type it in again.
It's not working.
Type it in again.
I did. Yeah, negative 3 over 2 squared.
All right, guys, I think some of you are having issues because you rewrote it in the right form, which is great. I'm glad that that's your first instinct. But when you rewrite this, that negative stays with that x squared. So it stays negative x squared minus 3x, and that's a positive 1. So when you're typing things in, my negative b over 2a shouldn't change. It's still the same values. But if you rewrote this and lost one of those negative signs, which I think is what's happened to some of you, that's why we're not getting the right answers. But when you're typing this in, guys, in your calculator, you'd have a negative from here, and then you'd have negative 3 over 2 squared. Like, you can't lose that negative that's out in front. And I think that's what happens is people lose that. Okay? That makes sense to help some of you out? Okay. Let's talk about some graphing. We're going to kind of bring all this together. So if you're still a little iffy, we're going to come back to the same skill, okay? If I asked you to graph without a graphing calculator, think back old school, 7th grade, 8th grade. You used to, guys, I'm sure, graphed a lot back then, right? How did you graph? You plotted points, right? You just plotted points. That's all kind of what happened. We're going to do the same thing. You guys remember XY tables? That's how you found all your points. What do you plug in for X? Doesn't matter. No. Right? That's typically where you start, right? 0, 1, 2, right? Like easy numbers. But now we're a little older. We got to look more beyond just 0, 1, and 2. Where else do we have to look? Negatives. So my suggestion here would be -2, -1, 0, 1, 2. Right? We kind of want to look what's going on the negative side, what's going on the positive side. We kind of got to go both sides of this, see what's going on. All right, so let's just kind of practice graphing a little bit here just by some XY tables. So if we plug this in, what is -2 squared? It is 4. What's -1 squared? 0 squared? 1 squared? 2 squared? All right, when you're making XY tables, it doesn't matter what you plug in, right? You can plug in any number you want. But we're just trying to get an idea what's going on. So now that I've got some points, these are all ordered pairs, right? We're going to plot some points. So -2, 4, back 2, up 4. Plot a point. -1, 1, 0, 0, 1, 1, and 2, 4. What's that shape called? Parabola. That's a parabola. Not parabola. It's fun to say, but that's not right. All right, so I want you guys to notice a couple things about this graph, because we are going to graph a whole lot of parabolas. That's what we're working on right now. So looking at this graph, what do you notice about it? It's positive. It's the U shape. We knew my A was positive, so we knew it was going to open that way, right? What else do you know about the points that you plotted? What do you recognize? They're the same but kind of opposite, right? They're like mirrored. I always think, did you guys ever do that art project when you were a kid? You take a piece of paper and put paint on one side and fold it in half and open it up? It's so fun, right? Those are really cool to do. But that's kind of what happened here. It's like I plotted points on one side, folded the paper, opened it back up, and there's the other side of the parabola. So, you guys know I'm a lazy mathematician, right? Oh, heck yeah, right? If I can do less work, I'm going to do less work. So, one of the things I'm going to show you kind of going up next is I'm going to show you how we can just find some of these points, and then we'll just mirror reflect them on the other side. Why would I have to find all of these? I don't want to find all those. It's a lot of work. I'm going to find half of them, okay? No. Mm-mm. All right, so here we go, guys. We're going to graph y equals 2x squared minus 8x plus 6. Is it going to open up or down? It's going to open up. My a value is positive. So, guys, do that little mental check, because if you go to graph something and it opens down and you're like, my a value was positive, you might have done something wrong. Okay? So step 1 is to find our vertex. So again, that's the negative b over 2a. So what we were just working on. What's my b value? Negative 8. So what's negative b? Positive 8. Over 2 times a, which is 2. So that gives me 8 over 4, which is 2. Stay with me, Deshaun. All right, guys. So we found the x part, right? Just doing our negative b over 2a. How do I find the y? We're just going to plug it back in. So I'm literally going to go back up here. I'm going to do 2 times 2 squared minus 8 times 2 plus 6. Right? So 2 times 2 squared minus 8 times 2 plus 6 should get negative 2. Double check, guys. If you're not getting the same thing, you got a serious button pushing problem. We got to figure that part out. Don't let the calculator be what's messing you up. Can you guys graph the vertex? You should be able to. You just found it. So 2, negative 2 is going to be down in here. So that's going to be the lowest point of my graph or the highest point of my graph? The lowest, because we know it should open upwards, right? So that's the lowest point of my graph. All right, step 2 is to make a table then. All right, so when we make our table of values, does it matter what we plug in for x? Nope. Now, let's talk a little bit about this. It does not matter. However, what happens when you get further and further away from your vertex? Think about the graphs. So as I get further and further away from my vertex, where are they going? Off my graph, right? The further away they are from the vertex, the further they are away from the graph. Like if I would plug in like 10 for x. Think about that. 2 times 10 squared. What's 10 squared? Times 2. Oh, my numbers are getting big real fast, right? And this graph is a 10 by 10. So we want to pick numbers. Again, you could put in anything you want, anything at all. But I want to be able to graph this. So we're going to pick numbers as close to the vertex as you can. Now, here's my suggestion. You guys listening? My suggestion. Wherever your x value is, I'm going to go 2 to the right. So what's after 2? 3, 4. I'm going to plug in a 3 and a 4. That is your best chance of keeping it on your graph. You can plug in a 6, 7, 8, 9, I don't matter. But it's going to not stay on your graph. It's going to be huge. All right. So just how I plugged in the 2 up here, if you're like me and you have it in your calculator, how easy is it to go back and just plug a different number in? Do you guys know how to do that in your calculators? If you just arrow up and highlight what you had just typed in, then you can go back and just change all the 2's you would put in for here, change them all to a 3. And I got 0. Okay, so all I was doing is taking this 3 and I was plugging it back in, just like we did with this and plugged it in. I'm doing the same thing. Yep. So just like we put the 2 in, but I'm just saying, like in your calculator, if you just typed in the part where the 2 was in there, just go back up in your calculator and highlight it and hit enter. And then you can just arrow in and just change all the 2's that you put in, change them to a 3. I'm a lazy mathematician, remember? I want to do as little work as possible. So same thing, now let's plug in a 4. So I'm going to change all of those 3's that I had in there, I'm going to change them to 4's. And I got 6. All right, so at all points through this, guys, as you're putting in x values, you're plugging them back into the original and you're just seeing what you get. Okay, so let's plot these points. 3, 0. So over 3 does not move up or down. And then 4, 6. Does that look like a parabola? It looks like half a parabola. So could I plug in more numbers to find the other half? I could, but I'm lazy, right? I'm lazy. So guys, right where your vertex is, that's kind of like we talked about the folded paper. That's that folded line, right? Where I put paint on one side and I open it back up. So if this point was 1 spot away from that folded line, where should the point over here be? 1 spot away. It's a mirror image. This point is 2 spaces away from that folded line. So I'm going to go 2 spaces away on the other side. And now I have my parabola. I can't draw very straight lines, so my apologies. You'd think, right? Putting lines through points, you could do it. Yeah, no, it's hard. It's hard stuff. All right, let's try another one, guys. Can you what? Yeah. All right, so guys, if I ask you to graph, what do we have to find first? Good, the vertex, which is the negative b over 2a. So what's negative b? Negative 8 over 2 times my a, which is negative 4, which gives me negative 8 over negative 8, which is 1. So the x value of my vertex is 1. How do I find the y part? Plug it in. So I'm going to plug it in. So negative 4 times 1 squared plus 8 times 1 plus 2, right? You're just plugging in. That's what you're typing in your calculator. And you get 6. So your vertex is at 1, 6. Again, guys, I like the dotted line. You don't have to do it. I like a dotted line. I like to see that visual like fold line, right? So I can see where I can reflect it easier. Makes sense to me. That line, would you be surprised to know that it has an actual name? It's not like a folded line like I refer to it. It's called the axis of symmetry. Sounds fancy, doesn't it? Axis of symmetry. All right, then we have to make an XY table. What number should I plug in? 2 and 3. Right? My x value is 1, 2, 3. Again, you can plug in anything you want, but chances are it's going to fly off your graph real fast. Okay? So we'll plug it in. So negative 4 times 2 squared plus 8 times 2 plus 2. And we get 2. And then go back and plug in our 3. And I get negative 10. Ooh, I just barely stayed on my graph. Is it possible that you go to find your 2 points and only one of them stays on the graph? Yeah. Don't panic. On your homework tonight, that's going to happen. Okay? Of course you do. It's math class. All right, so let's go ahead and graph this. So the point 2, 2. And then I always reflect it as I graph it, right? So I plotted 2, 2. That was 1 spot away from that folded line. I'm going to put another one spot away on the other side. And then 3, negative 10. And I'm going to reflect that one. And we have a beautiful graph. There's our parabola. All right, here we go, guys. Back to the math. So y equals negative 2x squared plus 1. I want you to graph. What's the first thing we do? The answer is 0. Well, the first thing you do is find your vertex, right, which is the negative b over 2a. I see why you're yelling out 0. Okay, good. So when you do the negative b, your b value is 0. So 0 over 2 times a. For those of you who don't know how the math works, there we go. I know some of you can see it, and I'm totally fine with it. All right, so it's just 0 for your x value. Plug it back in, and we just get a 1. Yay, so my vertex is at 0, 1. So that means it does not go left or right. It just goes up 1. All right, then we have to make an XY table. What 2 numbers should I plug in? 1 and 2. Right? If that's a 0, I'm going to go 1 and 2. Now, I heard negative 1, negative 2. That's fine, but I don't like negatives, so I'm going to avoid them. All right, so if we plug in a 1, what do we get? Thank you. And if you plug in a 2, so what should I do with those points now? Let's plot them. So 1, negative 1, and reflect it. And then 2, negative 7, and reflect it. And that's what our beautiful parabola should look like. Now, some of you might be wondering, why are we spending time graphing? Why are we doing this? No, it doesn't. No, this is an Algebra 1 standard. But I do it for a reason. All right, no. All right, guys, the reason I'm taking time to work on graphing, I need you to make a connection between something, okay? Because it is imperative to all of Chapter 5 that you make this connection. You guys with me? All right, so how is the graph of a quadratic function related to the solutions of the quadratic function? What's the difference? Why? They got to be something similar, right? If I'm solving the equation versus graphing it, they should have something to do together because they're the same thing, right? They all have A, B, and C values. They do. Let's go ahead and graph this, and then we're going to solve it. We're going to kind of see what happened here, okay? So if I graph it, again, I got to start with negative b over 2a. So we're still practicing here. So negative b would be negative 2 over 2 times my a value is 1. So negative 2 over 2, which is negative 1. All right, and then we need to figure out what that is. So we'll plug that back in. So negative 1 squared plus 2 times negative 1 minus 8. I get negative 9. All right, guys, this is imperative. We're making this connection as we get through this problem, okay? So that's my vertex at negative 1, negative 9. So let's make our xy table. What number should I plug in? 0 and 1, good. Because this is at negative 1, so I'm going to go 2 to the right, which is 0 and 1. If I plug in a 0, you get? No. No. Oh my gosh, stop guessing. If you plug in a 0, what do you get? Negative 8. So 0, negative 8. And reflect it. And then if I plug in a 1, is negative 5. Thank you. And then we're going to have to reflect that. And again, you're reflecting kind of over this folded line. You're not reflecting it over that y-axis. And I have students every year who think they are. All right, so wherever that vertex is, remember that's like where I folded it. So it's 2 spaces away. I'm going to go 2 on the other side. Now, humor me if you will. Let's put a couple more points on here. Humor me, please. If you plug in a 2, what do you get? Guys, this is not hard. Plug in a 2. Tell me what you get. It is 0. Thank you, Dylan, and you even did that in your head. Thank you. So 2, 0, and reflect it. All right. I want to make you put in the 1 extra point. Hi, great. I had this beautiful graph. You're like, so what? That tells me nothing, right? What if I asked you to solve this? Forget graphing for a minute. What if I just asked you to solve it? What method would you like to use to solve? We can factor, square root method, complete the square, quadratic formula. I'd probably factor. It does factor. So if I go to factor this, the last one's negative, so my signs are plus and a minus. They're opposite. Options for A, 1 and 1. Options for C, we're going to have 1 and 8 or 2 and 4. It's going to be a positive 4 and a negative 2. So if I asked you to solve these, right, you set each one equal to 0 and solve. That's what we did on our tests. Good. We x equals negative 4 and x equals 2. Okay, so I got those answers. I have a graph. Is there any relationship? Where did that graph cross the x-axis? Yeah. Look, where is this? Negative 4 and 2. I can graph an equation and tell you what the answers are by looking at the graph. Wherever it crosses the x-axis are your answers. Really? Nothing? No reaction? Nobody's impressed? So we graphed this, right? We saw those points right where it crossed the x-axis, right? That's where, I mean, we graphed it. I had you solve it. We factored it to solve, found that x equals -4 and 2. It crossed on the x-axis at -4, and it crossed at 2. So I would need you to recognize that when you're solving, your answers are where it's crossing the x-axis on the graph. So as we get into chapter 5, and I'm solving x cubed, x to the 4th, x to the 5th, and all of these things, how many answers does something like that have? X to the 5th has how many answers? 5. So if I can find some of my answers by looking at the graph, because we are going to move into the graphing calculator in that chapter. If I graph it in the graphing calculator and see where it crosses just by looking at the graph, I'm going to find as many answers that way as I can. Okay? All right, let's try another one. So graph y equals x squared minus 5. So if I'm graphing -b over 2a, what's my b value? 0 over 2 times my a value. 0 over 2, which is 0. Yep, plug that back in and we get just -5. So 0, -5. All right, so if you're making your XY table, I'm going to plug in a 1 and a 2. So if you plug in a 1, it's -4. And if you plug in a 2, it is -1. So 1, -4, and reflect. 2, -1, and reflect. Now, should I maybe go one more point? Did your graph, do my points actually cross that x-axis yet? Now, would I have a more accurate graph if I had another point above there? Yeah. So guys, my suggestion, if I'm asking you to graph it and solve it and kind of seeing that connection, make enough points so that they actually go across the x-axis. So let's plug in a 3. If I plug in a 3, what do we get? We get 4. All right, so they are actually one across there. Can you tell where it crossed the x-axis? Did it cross at a nice, pretty point? It didn't. All right, it crossed at like 2 point something, -2 point something. So maybe it's a fraction. What else could it be? A decimal, which in our world, because I don't let you write them as decimals, would show up as what? Besides a fraction, it could be a radical, because you have answers with radicals in them. So if I asked you to solve, what method would be the best method for this? So guys, instead of it being y equals, you can write equals 0, because that's what we're doing when we're solving. So what method? I heard somebody say +5. I'd use a square root method. So x squared equals 5. Take the square root. So x equals plus or minus radical 5. For giggles, even though I hate decimals, grab your calculator. What's the square root of 5? I'm so excited, Dalton. Let me use it. 2.2 blah, 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 blah. Goes on forever and ever and ever. Where did it cross the x-axis? What did we say? 2 point something and -2 point something? Yeah, it's exactly where it crossed. So in this case, is the graph real exact? No. I could tell it's 2 point something. In my world of math, I recognize 2 point something. I can recognize that as radical 5. My guess is in your world, probably not something that jumps to your mind right away. Okay? But now how important was it to have a plus minus? Look at your graph. Is it one on the plus side and one on the negative side? Yeah. All right. Solutions, x-intercepts, zeros, roots. You guys ever seen any of these words? All right. just a little vocab because it, depending on what textbook you're looking at, depending on what teacher you have, these words are all used interchangeably, okay? So the solutions to the quadratic equation are the points where the graph crosses the x-axis, right? So wherever it crosses, those are my answers. So these solutions are called x-intercepts, depending on what teacher you're talking to, right? X-intercept is where it's crossing the x-axis. They are referred to as zeros because what's the value there? What's the y value at those points? The y value is 0 because it's not up or down at all. Or the roots of the equation. So again, I could ask you, what are the roots of this equation? You'd be like, oh, she just wants me to solve this. What are the zeros? Find the zeros of this equation. It just means find the answers. Okay, so I want you to recognize the vocab. I could use x-intercepts, zeros, or roots. Me personally, my preference, I refer to them as zeros more often than anything else. So you'll hear me call them zeros. All right, let's do one more. All right, so to graph it, what are we doing first to graph? I have no doubt in my mind that Dylan knows how to do this. Some of the rest of you, I don't know. Dylan's one answering every question back there. Dylan, say hi. All right, what's negative b? 8 over 2 times 4. So 8 over 8, which is 1. All right, so to find the other part, let's plug that back in. I love you, like, what's 4 minus 8 minus 5? You're just going with what you heard, even though you don't know who it came from? It is negative 9. So 1, negative 9, way down here. And again, when you're reflecting, it reflects over that like folded line where your vertex is. Do not reflect it over the y-axis. It'll be wrong. Okay? That's why I like to draw the little line in so I can recognize it and I can count how far away it is. All right, so XY table. What do you want to plug in? 2 and 3, right? This is a 1. I'm going to go 2 and 3. So plug in a 2. Again, if you typed it in your calculator the first time, it makes it really fast. It's negative 5. And then plug in a 3. So 2, negative 5. And make sure you reflect it. And then 3, 7. And reflect it. Did it appear to cross at a nice point? Granted, I don't draw real great lines, but did it look like it did? I don't know. So, if I can't quite tell from the graph where my answers are, well, I really didn't need to do another point because I have some below and I have some above. Okay, so I graphed it nice. So how do I know what the actual answers are? I can't tell from the graph. What method should we use? I can't use the square root method because I have a b term. So do you want to factor? We can't use the square root method. We can complete the square. We could use the quadratic formula. Quadratic formula? Okay. So x equals negative b, be 8, plus or minus square root b squared, 4 times a times c, all over 2 times a. Yeah, so those of you who were hoping that everything we learned before would go away, it does not. All right, so we get 8 plus or minus square root 144 all over 8. What's the square root of 144? It's 12. 8 plus or minus 12 over 8. All three numbers divide by something? Yeah, they all divide by 4. So we'll get 2 plus or minus 3 over 2. Stop there. Good. Done. Now, what's 2 plus 3? 5 over 2. And then 2 minus 3 is negative 1 over 2. Where is 5 over 2? That's 2 and a half. Look where my, so there's 2 and a half, and then negative half. Will this original problem have factored? Do you have nice, pretty answers? I mean, they're fractions, but no radical, no I. That problem would have factored. We could have factored it. Okay, but guys, I need you to recognize these answers, they're right here. They are the points where it is crossing the x-axis. If we're not getting that, we are going to destroy in a bad way, chapter 5. Okay? Tell Mike.